Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at object initialization using your own classes in C++11, and we'll take a look at the delete and default keywords as well. So let's say you have a class here. Let's call it class test. So supposing this has maybe a couple of members like int id and string name, you can now initialize these in C++11 using the syntax that we saw before. So you could use this brace initialization to initialize these directly, and then these values are going to get, for every object, they're going to get the values you supply here. So let's maybe give this a public method called print, and we'll just make print do a cout for convenience here rather than overload the, well, I suppose there's no reason why we can't overload the stream insertion operator, which will be nicer, but maybe it's slightly quicker just to hack this together for the sake of this tutorial. So let's just do that. So I'll declare an object there, and we can do test.print now, like that. And if we run this, we find that our variables are initialized in the object. Well, if I get the syntax right, they would be. In fact, the problem here is that I haven't enabled my GNU compiler of C++11. Of course, you've got to do that. So let's just put that in. So standard equals C++11. Obviously, this is not going to work in C++98. Well, it's not obvious, but if you know C++98, you'll know that it won't. So here we've got every object is now initialized with these values. If you want, you can use the kind of old style initialization as well, but it now works in objects. So we couldn't do this in C++98, but now we can. So that also works. You can use an equals sign. If you define a constructor here, let's have a public test. Let's have a constructor that takes an int, for example, and uses that to initialize the ID here. Whoops, I'm thinking of Java there. Let's get rid of that public. So one thing you can do is, because the constructor is going to run after these variables are created and initialized, you can then create constructors that override the default initializations. So if we create an object here, call it test1 and supply it with an ID, let's say 77, and we do test1.print. So our constructor now is supplying a value for one of these. What did I do wrong here? But not for the other. So we've got, yes. So this is actually something I wanted to point out as well. So now I've defined a constructor which takes an ID, and the intention here is that the ID passed in is going to set the value for this ID, which will kind of overwrite the default value, but other members still have their default value. So this means that you don't need these long-winded initialization lists in your constructor anymore, when you just want a constructor that provides values for certain variables. You just need to deal with the variables in question, and the others that you don't want to initialize using your constructor can just be given default values here, which is very nice. Now, if you supply any constructor in C++, then you're going to lose the implicit constructor. And C++11 gives you a way that you can create implicit constructors without having to do a whole lot of work. So what we can do here is, here we can type this, and instead of having to put the curly brackets in for no reason, we can just say equals default, because this is a kind of a default constructor anyway. It's just that we lost it when we did this. So now this code works. If I run this, now it builds, and we can see that we've got Mike there, because with this constructor we set a value 77 for ID, and Mike was left at its default. So the constructor runs obviously really after the initialization of the variables. And we can use this to implement things that have a default implementation, but which we would sometimes lose if, for example, we defined, in this case, any other constructor. That works with a copy constructor as well, so we could do stuff like, if we want to explicitly say that we've got a copy constructor and it's the default version, we could do something like this. So const test test reference other, let's say, equals default. So we don't have to actually implement the copy constructor. Well, we didn't anyway, but this provides a way of saying, yeah, we want a copy constructor, we want to make that obvious, and we want it to be the default implementation here. Now, sometimes you don't want the default implementation. So let's say we could have, for example, there's also like an implicit equals operator here, and we can make that explicit by saying test reference operator equals const test reference other, and we could set that equal to the default. So this is saying, okay, we've got the default. It's just making it clear. It's not really adding any new functionality in this particular case. This did, because it replaced an implicit constructor that we'd lost. This is just making it absolutely clear that we're using the default implementations of these constructors. And of course now we could do stuff like test 2 equals test 1. That's you might recall that's copy initialization, so that will actually invoke the copy constructor. If we did something like test 2 equals test, maybe, because we've got a test object here just called test, this is invoking the assignment operator. So both of these work. They've both got their default implementation. But now supposing we want to make the object not copyable, just as an example, you can actually delete implicit implementations as well. So you can remove them. We talk about deletion in C++11. So if I want to make this not copyable, first thing is, obviously I want to get rid of the copy constructor, so I can set that to delete. And that means it's going to be removed. So if I try to build this now, the first line there is going to give me an error, because this is copy initialization. That actually invokes the copy constructor, as we've seen previously. And if I want to get rid of the equals operator, I can set that to delete. And then the second line there is going to give me an error as well. So, well, it's not so obvious, because we've got the error at the top there. Let's make sure that I saved it, because I just want to show you this working. So if I build this now we get an error on this line, because now we've got the copy constructor. That's fine, and this uses the copy constructor, but this line here is using assignment, and so we've deleted the assignment operator. That's not going to work. Let's just delete both of them, and maybe put in a block comment. So source add block comment, and we can just say there, won't work, we deleted them. There we go. So that's it for this tutorial. The most useful thing here is, well, it is quite useful to be able to replace your default constructor with the default keyword. The delete thing, maybe not so much use, but sometimes it's obviously going to be handy. And the most useful thing is really, I think, this initialization syntax, that is something that you naturally want to do and that you kind of type when you're a beginner, but it doesn't work in C++98, and now it does. That you can actually, well, as a beginner you type equals 7 or whatever here, and you can now do that in C++11, or indeed you could use this brace syntax in your class, and all your objects get these default values. So until next time, just to give you an exercise for people who like exercises, there's nothing really creative that I can think of here, but obviously it's worth practicing. Just define your own class and just do something to verify that default and delete work on your compiler as you expect, and try this variable initialization syntax as well. It's well worth just trying it out. You might find that this is not supported by your compiler. Don't forget to enable C++11 if you have to do that for your compiler, but it's possible. Still in 2014, it's probably possible that you might find compilers that don't support this syntax yet, so you might have to consult your compiler's documentation. But the free GNU compiler, as you see, does support it. Okay, so until next time, happy coding.